to the slides without.
Okay, okay.
So let me start to share my quest toward olfactory BCI, whatever it is, and I'll try to explain what different options I mean by this. And basically, the goal of my presentation is to present my research and to present methodology of upcoming study, which I'm about to start, receive feedback and update my methodology before conducting the experiments. Maybe avoiding some stupid mistakes I can avoid. So basically, olfactory BCI, what the hell it is? I don't know yet, but there are several options where we will be taking it. So why are we exploring olfactory BCI? Well, as my science advisor, Mikhail Lebedev, usually says in his presentation, first, any neurophysiological finding can be converted into brain-machine interface finding. So basically, it's just interesting. It's just, well, areas for exploration, because so far the olfactory data has not been explored that much in brain-machine interface. So we're just opening another channel for communication, but also olfactory is a unique sensory organ which opens interesting possibilities for us in this exploration. It's quite different from a visual or hearing sensory systems, or audio sensory systems, or tactile. So it is quite unique. So it's not just another channel, I would say. I would say it is a totally different channel, but there are limitations, technical and conceptual. So basically, it's with BCI, it's quite easy by now. There are lots of them, and usually that's a usual picture how we look at it. And there are some problems with olfactory when we think about using it in BCI. So while it plays significant role in animals, and there are a number of studies about how we can control rats by smells and all that stuff, and how all the animals react to smells, it has a limited significance for humans, especially for Western societies, where there are a number of studies of some weird tribes which puts lots of significance for smells, like they have lots of words for smells in their language. But for example, in the Russian or English, we don't have specific words for smells. We use it smells like something. It smells like lemon. It smells like coffee. We don't have words as such as we have for colors, like blue, red, which are categorization of colors. We don't say, look, the color is like lemon. Well, with lemon we can say it, sorry, but we don't say the color is like cherry. Okay, with cherry we can also
no, why? Come on, you can say пахнет лимоном, например. Come on.
Yeah, but that's the thing. But we don't have yellow, so we can say the lemon is yellow.
They don't.
But that's what I'm saying. So in Russian nor English, we don't have specific words for smells. There are research saying that there are some tribes which do have like basic words. But for Russian or English, we don't. And that's,
right.
And that's weird about smells. They don't have such significant role in our communication, for example. In the research,
if I can just say, like, for example, it would be completely different if you were using the same vocabulary for taste. So you don't say, it tastes like lemon. You say it tastes bitter, or it tastes sweet or something like that. So you do have, a specific word for it. You don't use a metaphor.
Yes. And here yes. Yeah, I agree. Yeah.
Yes, with taste it's limited, but we do have specific words. With smells, it's just absent. So, and also humans have hard time identifying and recognizing even familiar smells. So if we just have a smell as a stimulus, it is hard for many people to recognize what it is. They would say it is something familiar, but may not even able to name it, even if it is something really familiar to them. Some research suggests that humans just perceive smell in unidimensional space, with pleasantness is the only thing taken into account. So I can say, like, it smells good or it smells bad. I like it or I don't like it. Well, there are some research who says it's just unidimensional. The other problem is that there is no reliable system for coding smells. So we can talk about their chemical substances, but it's not like, again, with colors, we can use, I don't know, RGB or different other coding systems. With sizes which we see, we can also use different coding systems, like it is so many pixels or so many centimeters. With smells, it's way harder. There is no unified coding system. And technology for delivery is developed.
Sorry, it would be kind of, like if you count the number of like olfactory receptors in the brain at different times, you have like over thousands of them, and if you would be able to categorize like all of this, you would get like a really nice scale where you could actually do something like that. But I don't think that we even are getting close to the number of how many receptors we have in our nose.
Yeah, we can say that the olfactory system is quite understudied comparing to visual system,
Yes.
for example.
Yes.
And I didn't put it here, I should have. And also the technology for delivery. So like we have basically for visual or hearing, any computer right now can deliver image. So we don't have a problem designing experiments to deliver pictures or sound, but with the olfactory systems, it's quite complicated. So those are like negative points, and but there is also a number of positive points. So first of all, as I said, the olfactory system is unique, and what is specifically unique about it is the only sensory system that does not rely solely on thalamus, and basically it has direct connection with the brain. We can put it this way to put it simple, and it has connection with the limbic system, and with one can say that it has, well, and there are a number of studies showing that it has interesting influence on memories. So odor-related associations are durable and more emotional and evocative. And there is also another field of study called chemosignaling. So basically, we know that animals, so for example, rats, signal a lot through smells, like who's the boss there. And with humans, it's not as well, it's not in their conscious experience, but there are a number of studies showing that from the smell of a body or a human being, we can unconsciously receive information about gender, fear, and happiness. So basically, this is a general overview of this olfactory system, how it works. And as I said, so it does go through thalamus, and so all other sensory system goes, but it has this direct connection with piriform cortex and with amygdala, and as it says here, diffuse projection to the limbic system. So basically, there is a lot of things happening outside of like direct awareness. And right now, I'm just starting my research. So today I will be presenting, I'm presenting to you methodology for the first research which we'll be conducting in our center soon. And so we are just exploring olfactory sensory transformation. So what are correlates, EEG correlates for different olfactory perception. And further on, I see three possible different directions where this can lead us to. So first is BCI for olfactory attention. There is an interesting subfield of study about olfactory attention. And as I said, with olfactory, with smells, it's different from visual, where it's in visual system, it's harder to receive with olfactory signals, we have ambiguous signals, and bringing a person attention to the signal is quite a process. I mean, and there could be BCI helping this attention, like developing this attention, helping a person to recognize smiles and to engage into better understand what smiles are right now perceived. That's one of the possible avenues to take from for olfactory BCI. The other one is BCI for olfactory imagery. So basically, what we do with many BCIs is the person imagines that he or she is moving with a hand. Then BCI reacts. So the quest would be to develop BCI where a person imagines a smile, even if we are talking about a limited number of smiles in the beginning, but still, person imagines a smile and this smile is being delivered. So this is like second avenue for development. And the third one is just as olfactory as a feedback in BCIs, which are based on a different stimuli. There, the question is how to filter olfactory feedback from the signal we are reading and recognizing, for example, what person is, which hand he is moving, or is he concentrated. Well, let's say if he's on alpha wave training, and then we need to subtract data which is now generated by olfactory. So those are three avenues for the further research. But right now we're just here on a olfactory sensory motor transformation, and in order to achieve results, we need to deliver smell and how to deliver odors. There are quite a number of studies which use just manual delivery of odors, where assistant just brings a container with a certain smell to a subject, like this one from Saha and others from 2013. And here EEG is being recorded. And there are a number of, well, this is like, let's say, analog method. And it is good for the beginning probably, but it has a number of limitations and has a number of questions to the consistency of the delivery of the smell. Do we have all the time the same distance? Do we have the same intensity? Is it onset, on time, and all those questions? So in order to deliver smells, there are such things as olfactory display. Haven't known this word before I studied this endeavor. So olfactory display is something which is used to deliver smells to a subject, to a person. There is a lot of studies in entertainment industry which wants to use them in virtual reality. So there are different types of olfactory displays, and manual can be assigned to the first type, where just scent generator is being used. And well, basically the problem with olfactory is that it is based on chemical signaling, while visual or hearing is based on physical signaling, and we are way better, we have a way better developed technologies for physical things rather than chemical things. So in my experiment, I will be lucky enough to use a laboratory which is called Sensory Lab, which is situated in Moscow. They've been situated in Skolkovo, but now they've moved to Neurotrend laboratory. So it is a cube like this one. Do you see my mouse, by the way? No, but yeah.
Yes, we see your mouse.
Okay, thanks. So it is basically this cube. That's how it has been situated in Skolkovo. Now it looks a little bit different. And in this cube, there is a person, and there is this thing here on, like, this is a picture from the cube, and it's hard to make a picture of the cube. And there is this ventilator and on top of a person, and stream of air is constantly moving from up to down because there are two holes in the bottom. And in this device, there is 4 capsules for odors, which have piezo elements, which can be turned on, and then this odor is being injected into the stream of air. So basically, it can be assigned to this type of olfactory display. And it is perfect. I really like it because it has an instant smell onset and offset. So basically, when the smell generator is turned on, you just instantly experience the smell. And when it's turned off, because the constant airflow, it just disappears immediately. That's the problem with the smell, which can stay for a little longer than, well, when I remove the source. It's run by a simple code. It can use up to 4 different smell cartridges. And we can control intensity, so it will be the same for the whole duration of the experiment. And also, what I like is
can you just like describe this smell cartridges and what's inside them?
I use well, basically it's a small piece of tube which
Yes.
which is well, there are 2 types of them which are right now we are right now testing. One is just a small plastic tube which you put on piezo element, and then it's, and the other one, it has underneath this tube, it has a small piece of kind of a foam. I don't really know the name in English and no Russian.
Right. But what's inside them? Like, what kind of chemicals do you use?
So I will be using well, inside can be any kind of oils, like, but so I will be using particular artificial molecules which are have a more constant smell, let's put it this way, which can be bought in a fragrance shops. So there is particular fragrance. So basically, but it can be also used with the natural oils. The problem with natural oils is that they have more different compounds depending on time of the year they've been collected. So all those things. So basically, yeah, you put this liquid material in any proportion in this tube, and this tube is put on a piezo element, and piezo element just well, when it's on, it turns liquid into humid, which is being injected, which is being just taken by the constant flow of air.
Well, the piezo element, as I understand it, opens up, right? It gates the delivery of the order, right? It just opens, physically opens the container, right?
I hope that Nikita will join us at some moment. We can explain it a little bit more. So Nikita is the head of sensory lab, but I think he have not been able to join it. He's right now in another meeting.
But also, yeah, also Ivan,
yeah.
You mentioned when we were speaking about the tube, right? What I was thinking is maybe a good option would be to have a tube which would be like sort of a closed loop, right? And you just stream the air through it, and the tube is passing your nose, and it has some perforation here, so that you can some of the air gets out and releases the molecules, and then it will be, I think it will be more controlled, because see, I mean, you're sitting in this room, right? It's pouring you the air with all these molecules, and they will be stuck on your hair everywhere, and you will after some time you will perceive the combination of smells, really, because the whole, I don't understand. I mean, you can suck it out of the air, but you can't suck it out of your hair, skin and stuff.
That's a good question, but there are also problems with the tubes. So, for example, if you use the tube from the scent generator, the part of the smell molecules will stay on the tube. So when we change the smell, it stays there. So in this case, it does stay. For example, like my personal experience, when I'm sitting under this thing, when the smell is turned off, I just feel fresh air because it's just constantly going. But if you stay like nearby the subject, some molecules stay there because the flow is going
Okay.
like this,
Right.
and they stay here. So here under my nose, I just experience constant flow of air. So it's just like a breeze of air constantly, you know, like going in front of my face.
I see. Okay. Okay.
So far, I find it as a best option. Also, the other problem with the tubes being here is when you focus on a smell, you also focus, you put your attention to your nose. And when there is this tube, it kind of distracts you. It's kind of, I mean, you are right now trying to recognize the smell, and it requires you to put your attention and to bring memories of that smell. Where did I experience it? And then there's this tube which kind of limits.
Well, maybe, but well, the question is, if you're asking about comparative analysis of what happens in the brain when you perceive different smells, for instance, then in all of them you have this tube, right? But you get used to it. Come on, you stop noticing it, I believe. Yeah, but this argument about some molecules staying in the tip or in the perforation, you know, yeah, that's maybe one of the reasons why it's better to use this sensory lab equipment.
Yeah, it does require, after some time, it should be like experiment should be stopped, and air should recirculate all around the place. But basically, this constant flow allows it to change.
But for how long? For how long can you conduct the experiment without the need to refresh the air?
Well, I think half an hour.
Ah, okay. And then the duration of presentation of which stimulus, of which other, what is the duration? The minimal duration?
Milliseconds. I don't really know, because it wasn't the question.
But you won't be able to perceive it if it's millisecond. I think.
Yeah.
Well, the question is.
For my research. For my research, I will be using it for 3 seconds in order to.
Okay. Well, that's okay. Yes.
To record EEG at the time. Then it's a good question. It's like
no, but 3 seconds. No, I'm just trying to put together this 3 second stimulus presentation and about half an hour running time. That would result into a reasonable number of stimuli. Yeah.
Yeah, and then the recirculation is not that long. Okay, so let me then proceed to. So, or maybe there are another question about the laboratory equipment. Okay, if we are done with the equipment, I will proceed further to talk about my first experiment. So we will be recording EEG signals for subject processing different odors in clean environment, and analyze data to categorize EEG for different odors, or also for correct and incorrect trials. There is a more explicit description of the hypothesis, which I will have, but basically, first we'll be doing it for the recorded EEG, then we'll be trying to stimulate real-time categorization, and in the next experiment, try to work in real time. Here, by real-time, I mean my categorization should be working on a streamed recorded data. And also not only for different odors, but for correct and incorrect trials. So this is kind of an interesting question, because I will come to it in more details later, but the idea is that we can, the question which I have, is it possible to correctly categorize smell from the recorded EEG, and while subject will be wrong about the smell, and also can we see when the subject is wrong and when the subject is correct? So when they perceive the smell, are they correctly perceiving it or not? The general
then you really have to hope that theory that this is just like one-dimensional thing is not correct.
Yeah. I think it would be an interesting addition here to because see the fact that the human is making an erroneous decision, I think it has already been studied, and at least I read quite a bit of papers on it. But I need to look for them. And Vasily knows quite a bit about it. I mean, if you ask him, Vasily Klucherev, they studied the decision making stuff, and but it's interesting what would be specific to errors in olfactory perception, okay? And I think for this experiment, if you want to study that particular thing, you want to add some other type of stimuli, maybe visual stimuli, maybe something else, where of comparable complexity, so that people make decisions and make mistakes as well. And then you can compare mistakes made during the visual presentation of something, whatever, I don't know, some task or auditory recognition experiments and olfactory recognition experiment. And then you may find maybe delineation, maybe you find a common mechanism, and maybe you will be able to find the specifics for olfactory and for other type of presentation, for other sensory modality. That would be really cool. Yeah.
Yeah, it would be like really cool if you see that, like the CPU is the same, just the input is different. That would be very,
Well, yeah, then you will find this. You will find the common part, because unless you find the
yeah.
common, unless you have some other presentation of the stimulus, uh, you will not be able to say that this is the common mechanism and that's the sensory modality specific part.
Right, right.
Yeah.
So that's an interesting further development. Yes, okay, I wrote it down. Thanks.
You can
And
just put a note here. Yes. Yeah.
yeah, and so, but going further to the current design of my experiment, it will have those basically training sessions and guessing sessions. Okay, there is this intro where they will sign all the necessary papers and where we will set up all the necessary equipment. Then there will be a set of training sessions, a short rest, and Q&A where they will fill in a form about those smells. And then there will be the guessing session, the real one. So basically, the experiment setup that will be for 3 different odors. In the beginning, I will be using 3 totally different odors, but I found that people have had hard time differentiating even between familiar odors. But later on, in the next experiment, I will be going for more similar odors if my first experiment will be successful. Subjects will be replying with a joystick. Joystick has been chosen to take advantage of the data available from the previous experiments from Baldert and al. So they have recorded data for onset of the movement, and will be using it to separate it from the data for the olfactory processing. Joystick can be moved in 4 directions, so that's what allows us to have 3 smiles and 1 direction for no smile condition. And joystick also can be pressed. We'll be using it to initiate new trial and also to make a mark on EEG. I didn't put it in the presentation, but the idea is that when the person will be pressing the joystick, there will be also basically mark on the empty channel of EEG, which will allow us to synchronize data from the recording from the moment when the smell delivery has started.
Hold on a second, one. And the question, because I mean, it's better so if we give you feedback as we go, okay? Because otherwise it gets forgotten like blood. Okay, so the question is why why did you decide to use joystick? Because it's quite a bit of movement, actually, and also a lot of tactile component to it. Like because if you, for example, if you're sitting and holding the joystick all the time, then there is a very strong confound of your hand and stuff like that, right? Of your tactile and proprioceptive things, which go up into the brain. And if you're just sitting still and then reaching to the joystick, then there is a lot of movement, including, the whole body movement and things, okay? It's much more customary to use a pad, with the specific special pad with buttons, like 4 buttons is a standard standard thing, where you put them under like 4 fingers and you use them. It's just much more standard. So the question is, why do you want to use joystick?
So there was this experiment run by Valdert, where they had a particular setup for joystick, which has been used, well, the person uses only wrist to guide the joystick, which will be repeating. And there is a well-recorded data on the onset of the movement and offset of the movement. And then the idea was just to take advantage of this data. I don't know. I'm open to change it.
Did they report like the if they did, you know, like some sort of interviews after with the candidates, like what was the perceived, you know, like error rate from the candidates? Because, you know, like every time you have to think, you know, like, oh, where was this? Like, was it up or was it left or whatever, you know, like, so, you know, people, and also you will probably be measuring, you know, like response times and stuff like that, you know, and I need to process this. I need to think where I should move. While, you know, with the pads or you know, touch screen or something like that, it would just be there.
So there is this standard topic, sensory motor transformation, that it is usually done with the joystick, because the movement is really simple, and with the pad you add more complexities, single finger control, etc. And also this directional tuning curve is pretty simple. So like if you do this finger movement, then you turn it into a finger movement experiment. So some very simple response, but still to have motor response instead of report or something, like so that you can analyze long periods of time, like when he smells, when
but
he
just like somebody suggested here, you know, like also eye tracking could be like a really nice idea.
Sure, yeah. Eye tracking could be nice, but then the subjects probably will get tired really soon, and that is also unnatural.
And also very hard, much harder to control. I mean, like you have to somehow control. You know, it will be much more difficult with eye tracking to really, let's say, detect the moment when he or she is making a decision, right? Well, because the eyes are moving all the time anyway, and so you may wandering around and so wandering, yes. So yeah, okay.
But like if it works, then you can add on whatever you want. You can connect it to. Like, I don't want to interrupt the stream of this. I'm actually curious about what are you looking to find in the EEG, like specific to smells.
Yeah, but maybe we can. This is very interesting. I think this is one of the most interesting part. So maybe when Ivan tells us about this, we'll discuss it, right? What do you think?
Okay. Yeah.
Okay.
Ivan, will you talk about? Yeah, go ahead.
Yeah. So basically, I'm open to changing it to pads, but right now joystick seems as a valuable solution, and as Mikhail have said, it's has a standard which will be
there will be like delay period when he knows how he wants to respond, is not responding yet, so
but he's
like,
and he is not holding the joystick all the time, right? He reaches to the joystick, right, somehow, or right before the response, you know. So because his hand is above the joystick, right? And then he just because what I'm concerned a little bit is that it may happen that for some smells, for instance, you will have instinctive, you know, subconscious, you know, like intention to press the joystick, you know, and then you will have all this feedback that you may confuse with actual olfactory response. So it's important to make sure that, well, joystick is fine, but then as Misha said, that before you are making, when you are making the decision, your hand is lying still without any extra pressure, without anything. So you're not moving your fingers or stuff. So you're still, and then once you then you're, then you make a response. Maybe it's some sort of a, maybe some sort of a sensory screen is better, like, because if your hand is lying on the sensor screen, for instance, like this, right, just lying, and then when you need to make a response, you're doing this or this or this, but then you're lying. And then if during some trials you are instinctively moving, then you can reject those trials, no, that's just an
Yeah, I mean,
idea.
Okay, so I see that there is this question about how do we want to maybe
Yeah, how we want to
upgrade
register
the
the
joystick or register signals. I think they will. I mean, we'll be discussing it with.
yes.
Yeah,
I mean, like,
there is also like one more feature. Smells are 1, 2, 3, but the report is for 1 is not always in one direction. So it can be to the right, to the left, depending on how the targets are arranged. So this way you.
Yeah, for the subject it will be different.
Yeah,
then you will randomize it, right?
Yeah,
Yeah,
exactly.
for each subject it will be different.
And during delay, you don't even show
So let me go
the
further
targets
to
yet.
explain the experiment,
So,
and maybe it will answer some
yeah.
questions.
Okay.
So the smell is delivered 3 seconds after joystick is pressed. For each trial, computer randomly chooses smell or no smell. For 3 seconds, subject is asked to remain calm and focus on the smell and not to express your guess. After 3 seconds, 4 errors appear on the screen. Subject is asked to make a guess by moving the joystick in desired direction. After joystick has been moved, the smell delivery is stopped. Clean air is being delivered. And yes, for each subject, the smells will be assigned randomly. Here it is. So the difference between training sessions and guessing sessions will be the following: that during the training sessions, 1 error is being highlighted to show which order is being delivered. So in this case, what I achieve is that subject learns orders, but doesn't explicitly receive names or labels. I believe that this allows subject to fully engage into olfactory awareness. So we don't call it lemon. It's just he knows that this is some smell he receives, and it is to the left. He can think it is orange, mandarin, or I don't know, New Year. Like it is his personal inner name, but in our case, we have an arrow which is assigned to it. And for each subject, all orders will be assigned to directions randomly, which allows us.
Hold on. But you just mentioned, hold on. That's something I don't understand. I don't understand this and the previous comment on the previous slide. As far as I understood, like here you're saying that each order is associated with an arrow, right? Like order 1 always goes to the left, order 2 goes to the right, and order 3 goes up, for instance, right?
For each subject, it will be a random assignment. So for me, lemon will be on the left. For you, lemon will be on the right. For Mikhail, lemon will be up.
Okay, I see. Okay.
So we'll have the setup, and it is generated for the subject. Basically,
I understand the motivation for this, but you have to also consider, I believe, well, I mean, there is a lot of inter-subject variation for sure. I don't know how much is an olfactory perception, but in other stuff, a lot. Here, you're basically relying on a cross-subject design. I don't know if I'm naming it properly, but you understand what I mean, right? You will be averaging over subjects to get rid of this confound, of this possible confound of the direction, right? That's something I would think. I'm not saying that this is wrong, but I would really think of how you process the data, and I would try to appreciate how many subjects you need for that and things like that, because this might be a tricky part, okay? Because yeah.
Do you think that if we'll be using numpad, it will not be a problem?
No. I'm not saying that. No. Again, I'm not saying this. I'm just saying that this is something to keep in mind, because if you're within subject design, if you're doing a design where within subject you can get rid of all confounds, for instance, right? Well, then this is one type of design. But here you explicitly have to go through like group of subjects, you know, in order to
Yes.
get rid of this confound. And then you have to think about the normalizations that you would use and things like that. Maybe you need to think about recording, but for sure, you need to record the baseline sessions in EEG for sure. And you have to think of how long they should be. And maybe these baseline sessions should be like maybe several of them, like in the middle, in the beginning, and in the end, you know, some sort of like references. Yeah. Okay.
Thanks. And also, yeah, maybe also with movement, just without.
Just with joystick without, yeah. So think about it, because those references are very, very important. They will simplify your life, and they will simplify answering to the viewers' questions in the future.
Thanks. I to put a mark. So basically, screens will be the following: the first screen, and as person presses on joystick, it says start focusing on the smell, which in Russian is listening to the smell, which I don't know. Sometimes is weird even to me, but nevertheless.
Предчувствуйте запах.
So in this case, the person is instructed in the beginning that while it is focused on the smell, you do not move. So you just listen to the smell. And then it is, for a short moment, it says, choose the smell, and then those 4 arrows appear. In the learning trials, one of them will be highlighted. So the person is just, okay, look to the left, but he or she is just recognizing, okay, this weird smell is on the left, this weird smell is on the up, or this familiar smell is on the right. So I want to talk briefly about similar research. So there are 2 groups that have recently conducted studies on olfaction and EEG categorization. It's a group in India and a group in Turkey, run by Demir. And they have reported, well, their papers have been published in, not in psychology or physiological journals, but in computer and data processing, like engineering and neural processing and neural computation papers. So they reported to successfully categorize recorded EEG data for different odors. In their experiments, they used manual delivery methods. So they basically just brought odors to the nose of the participant. Their focus is on they focus on their papers mostly on the computational models, which I hope to take advantage of, and they do not include anyhow subject awareness of perceived odor. So it's not, so they do not record, they do not ask participants what smell do they receive, do they understand it, can they recognize is this the first one or the second one. And they didn't apply real-time categorization. So my quest is also to train a filter for categorization for BCI in order to have it as a real-time categorization. So let me just also.
Ivan, sorry. What do you mean? Sorry, I might have, my attention was switched off for 1 second. What do you mean didn't include subject's awareness of perceived odors? What do you mean awareness? Meaning that when they're solving this task of recognizing which smell is which number, right? You mean this?
In their experiments, subjects did not recognize it.
Okay.
They just were sitting there. So they just bring one odor, next odor.
I see. Okay.
Sitting and smell and receiving the signal without any information about their process.
Right. I see. Okay.
They just, I don't know, like they can be also unconscious or sleeping, but okay.
I understand. Yeah. So it's more like not really conscious, but yeah, I understand that.
So that's where I want to bring you. My last slide, where I kind of have this BCI scheme, but not also. But usually in BCI we focus on like computer, how it works. here I want to talk a little bit about how in human brain we can divide different processes. So basically, and those comparing to the experiments you just asked this focus, basically our BCI can work only on sensory systems, and there are some BCI which works only on sensory systems. Basically, for example, depending on which rate picture is appearing, we can record from the sensory visual system of a human being where he's looking, right, on the picture which is appearing with one rate or another rate.
You mean those are so-called SSVEP, steady state visual potential based
Yes.
BCIs? Okay.
Yes, and in this case with olfactory, also it is possible. It's not yet, clear, but for example, it's possible that in Saha experiment or Ademeyer experiment, they just recorded from the sensory system. Though with the olfactory, it's really hard to separate olfactory and signal processing, like sensory system and signal processing system, sensory processing system, because it doesn't have such clear boundaries. But nevertheless, what I want also to bring to attention is this awareness, and basically, we can. In this case, we can record and we can explore to which extent subject is aware, and that's where basically you propose to take all this with comparing this awareness in different modes with olfactory, visual, and so on. So basically, this would be one of the focuses of the research. To which is it possible that EEG is that the network which has been trained on the data can recognize which smell is being delivered, while human being is not able to recognize which smell is being delivered? And is it possible that we can see what exactly the signals which correlate with the recognition, with the awareness, so human is aware of this smell in the correct way? So it's not just aware, but kind of correctly aware.
He knows what it is.
Yeah, he knows what it is. He recognizes it. But this requires some conscious processing. And in this case, can we, for example, train a BCI that can be helping this conscious exploration? So kind of having different other stimuli like visual feedback when the human is moving towards a correct understanding. But this is for the further explanation. Right now, it would be just basic exploration here and here. Can we see the difference between correct answers and not correct answers? And can we see the difference between odors? That's pretty much.
Do you have an assumption, like how many trials would you going to need to build a classifier?
Well, in the experiments run by Ademeyer and Saha, they used a really small number of trials. Let me just see. I will be using up to 20 trials. That's my current estimation based on my discussion with Mikhail Lebedev.
There is a well, it's actually quite complicated, I think. If I may comment on what we have heard so far. Depending on the type of smell, right? You will have really very different smelling behavior. You will smell differently. Like imagine, like you will have different breathing behavior, right? Voluntary breathing will be very different. Like, for example, if you're like very simple example, if you have a foul smell and you have a pleasant smell, right? You will subconsciously try to avoid the foul smell. And at the same time, you will be like more freely listening or perceiving or inhaling the pleasant smell, right? And that will already be a very, very strong confound that you will need to somehow resolve. Like if you have colors of like more or less equal valence, then still, if you are asked, for instance, if the subject is asked to distinguish between two different smells, which may be close to each other, right? Some subject way, then you will be inhaling more intensively when you are presented with these two difficult to distinguish smell, as compared to, let's say, the third smell, which is, which is far away, right? And that will not be about actual olfactory response, right? But it will be about voluntary smelling. But at smelling, you will also be having lots of oxygen, and because of oxygen, your activity brain activity will be different, obviously. So, I mean, this is a very serious confound, okay? So that's
how can it? What do you think will be implication of this confound? What do you think?
Well, because you will be distinguishing not the smells, but you will be distinguishing the behavior of a person during perceiving a smell. So you will see this in the EEG.
Mm-hmm.
Okay, and it can be both artifactual if you're like breathing and like moving and stuff, but it can be genuine brain activity, which is different, and also genuine brain activity, which is partly controlling, making voluntary signals, producing voluntary signals to initiate the extra smelling, things like that. That's one thing. Another thing, what I think is your experiment in its present form. What the fact about awareness that you mentioned is actually very, very interesting. But before I talk about this, I want to say that you're learning to associate colors with directions, for instance, right? It's an interesting thing, and this is what Misha suggested: this olfactory motor integration or whatever. But it also will have a lot of reinforcement learning component to it. Okay, because you will be learning to discern this, and the only thing is it really reinforcement learning, because you will not be actually making during the training session, you will not be making any actions, right? So it's not like operant conditioning, right? It's something. So this is very so the reason, basically what I want to say is that the whole thing is very complicated. A lot of things are mixed into one single experiment, okay, in a single design. Okay, it will be very difficult to unravel all this knot of causes and possible reasons for the type of data that you observe, okay, and for the differences that you will be able to find, right? So, well, when you talk about the awareness, I think that could be maybe as a first experiment, at like zeros experiment, okay, not the first, but as a zeros experiment, as a pre-experiment, if you will, okay, to conduct this awareness-free kind of experiment, and to get some experience of the data that you get of, like, if you, of course you will have to have a breathing sensor, right? So that you will know exactly how the person is breathing. Here, I'm not sure if your big breathing sensor, which is the belt-based system, is good, because I'm just thinking of, like, if you're smelling, you may be smelling very, very short, very, very shallow style, then will it be reflected by the sensor? But it doesn't matter, you can find it out. But so try to control as much as possible, and do the zeros experiment, where you do awareness-free smelling and record EEG, and try to see like we can call it pilot study. Yes, yeah, because again, there is a lot. Well, and I'm not a specialist in cognitive science at all. Okay, so I'm just a signal processing guy. That's it. And even for me, this design has like a lot of alarms. Okay, I can imagine if like Boris Chernyshov or somebody who is aware of cognitive things will listen to it, he or she will have a lot of comments. Okay, and I think it has to be. Well, I mean, you have to think more carefully about the design and about the components which you want to disentangle, and how you will disentangle, and the control conditions, so that you will match one condition against the other, and be able to highlight a specific feature of cognitive processing, and other components that are taking place in your experiment. Okay. So that's.
So, but if I can give you one suggestion, like, because I used to work with rats, and like, rats just like to lick stuff. And when they know what they are going to get a reward, they, like can get very impatient and just, not pay attention to the stimulus at all, but just straight go for the reward. And then you just put a variable that's called too fast, and then you ignore this kind of trial. And here you will, you have an assumption of how much time does it take, for the the processing to occur. So, you record the signal and then you truncate everything that's below certain threshold, and you do not look at that part of the signal at all. And that, might solve something.
Maybe yes, but also Vladimir and Ivan, as someone suggested here in the chat, but in this design that you have, when you are listening to a smell, okay, and if you are listening to a smell during already, let's say, training stage, in the end of the training stage, or during the recognition stage, if this sensory motor integration works, then you will even let's imagine that it will work on some sort of even subconscious level, right? Or like slightly, I don't know if it's possible to say so, slightly conscious level. But anyway, you will be listening to a particular smell that is associated with arrow to the right, and you will be instinctively looking at this arrow that is to the right, okay? And then you will have eye movements, and of course you will have some motor activity associated with it, because you will be preparing to move your joystick to the right? So this is also something that you need. So you don't, you show the screen, as was suggested, will show the cross, and you don't show these arrows this is at least. But also, if this of course does not preclude the person from planning this movement in his or her head, like imagine, okay, that's the right, okay, I got it, yeah, that's the right, okay. So
I have an idea.
Yes.
Will it make things worse or better? Just tell me. So, for example, we'll have not arrows, but some objects like square, circle, star, and whatever. And they will be appearing randomly. So I cannot think about moving to the right, because I don't know, will the star will be on the right or on the left this time? Will it help or will it make it worse? Because of the
this may help, but I think other people can also comment. But maybe why don't you just imagine that you're at the, okay, you listen to the smell, right? You recognize it. Okay, 3 seconds passed. You have like 1 second. You recognize it in your head, and then you put like objects, like as you suggested, or just numbers 1, 2, 3, and they will be every time in random order. Okay, and then you will use your mouse or whatever to choose the answer. The joystick, whatnot, it doesn't matter, right? You can move and choose the answer. Then you will exclude the planning response, related to the movement.
So basically, instead of arrows, we can have numbers to motivate.
Yeah, no, but the point is that it
the
will not be arrows. Yeah, they will be random. Yes, they will be randomly allocated. Okay, or you can have colors. This is actually very interesting, by the way.
Colors make it like cross.
Yes, but you can study this. You can say that, okay, you can compare. But I presume you will need to have quite a bit of subjects for that. But you can also, like in some subsequent experiments, right? You can choose, for instance, now numbers, right, or shapes, right, geometric shape, and then you can choose a color, and then you can see the differences. What are the distinct processes which because otherwise the experiment is exactly the same. It's just you're associating the smell with the color. On here, you're associating the smell with the number. On here, you're associating the smell with the geometric shape. I mean, that would be really cool. And you can actually have like the first experiment you run yourself, and then you can have to run similar experiments. You can hire a student, for instance, right? And this will be a perfect project for a student, because you exactly know what you want to get in large, right? Because you have your first experiment and you trust it. And then you see the slight variations, and I think this is pretty cool, actually.
So
You know, like
I like the idea of visual objects because this adds some visual processing. So this is good. So I like.
Yeah.
And also,
yeah,
if you place them in random positions,
Positions. Yeah.
then this direction is unpredictable. So this
Exactly.
is
Yes. And you will not be
another good.
planning, right? You will not be, when you're listening to the smell, you will not be planning. Okay.
Mhm.
So yeah.
Yeah,
So even if you don't record olfactory related signals, you will record something visual, motor. Yeah. So
Yeah. Also, there is this there is this thing about, also think about it, but not in this experiment. You will not be able to study some sort of top-down processes. For instance, you first present the smells, just present the smells, and then people, and then after some point, you will teach them to associate smells with numbers, and then you present the numbers to then, to recognize actually. And then there will be big difference between the first and the second experiment, because in the first experiment you never experienced these smells, and in the second experiment you have already experienced them, and you can see the differences and try to interpret them as a top-down influence, because you may be predicting something, you may be plotting something, so yeah, that's further.
I will have to, yeah, I did not really understand the whole design you're proposing for the next ideas, but right now what I've got from our discussion, which is like the aim of my presentation, I will be updating my design to the arrows, and the question is, what should I be using first? So there are options, symbols, numbers, or colors. Should I go with symbols, shapes?
I think symbols, shapes is good. Yeah, I think the square, the triangle, and the whatever, the circle. I think that should be
yeah,
more than.
symbols are good, but you should also count your trials, like count all
Yeah.
combinations, and so that it is reasonable, so that you don't require 10 hours to cover everything. Yeah.
Also another concern of mine. It may be partly resolved here because you have three smells, right? But the olfactory stimuli are known that you really are getting used to them very fast. So you stop noticing them. That by
that's also a
itself.
question. That's a
Yeah.
question whether will they have it. It will also be a question like on the form.
So you may have some very different behavior in subject during the beginning and by the end of the experiment. So maybe you will have to have a break, but of course the break will affect what they've learned, because they will start forgetting what they've learned. But at the same time, they will start regaining the sensitivity of their receptors, right? So that's also another interesting question. What the time between, because yeah. So that's something also has to be looked in the literature or taken into account.
So
Well, you know what? There are other things. There is one other thing. You can study, as Vladimir suggested, I think, you can study this also, kind of subconscious, non-awareness experience. Like, for example, you have some smells that everybody knows, like a lemon and coffee, okay? Those are different, right? And then you can do the pilot and you can see the reaction time. I think Vladimir suggested measuring the reaction time. And you can see how this reaction time progresses as you go into the experiment. And this might give you a rough timing of the experiment that where you have more or less flat performance curve, which is not confounded by this habituation, whatever. I don't know how you call it properly, but something like habituation response. Yeah. Yeah.
Okay, so it seems like I will be starting with this, just with shapes, and
Yes.
then
I think
keep in
shapes
mind
is good.
to
Yes.
have numbers and colors for the future experiments, especially.
Yes, for the future. And also, yeah, I would like, if I were Mikhail, I would insist on the pilot experiment with in the non-awareness design, so that to streamline the whole thing, to see what kind of data you get, you will learn a lot from it, a lot. And this is a cheap experiment, in a sense that it will not require a lot from you. You just, but then you just look at the data. You will really have a lot of insights, and then I'm sure you will redesign again, I don't even know in which directions, but you will redesign your main experiment after that. Yeah. Well, not completely, but you know, you will add some very necessary, very needed amendments. Yeah.
But if you combine like this, if you want to, you know, like in the future do this with colors and whatever, it for me it would be like really interesting if you would be able to regroup like the same subject that we're using, you know, in the and then you know repeat the same experiment, for example, in the first one with the objects and in the second one with colors, and then see the difference, you know, because like somehow I think that you know like colors also have you know like a certain emotional impact with
Oh, for
anyone
sure.
else.
Yes,
So you
yes,
know,
yes, yes,
yeah.
yes, yes. Yeah. And also,
Also,
yeah, go ahead. Sorry. Yeah.
just right now came to my mind, like there are those, I don't remember how it's called, but when a person have this mixture of sensations from a source, like when they see color and then they have a taste.
Yeah,
Yeah,
it's
that's
synesthesia or
yeah,
something.
synesthesia. Yes, exactly
Yeah,
right.
so it could be also interesting to see if there will be different, well, how different it will be in such an experiment for people with synesthesia.
Синестет по-русски, синестезия. Yeah.
Synesthesia, yeah.
And
But
also,
there's also another like way how to make it more complicated while I need to make it simpler.
yes. Also, you know what? There is other thing. The smell perception is has a very associative nature, as already mentioned now, right? So you will associate it with like with events in your life, with whatever. Therefore, I think if you're in cases when you use familiar smells, well, more or less familiar smells, right? Something that you can name, like lemon, cinnamon, like coffee, you know, things like that. You will have very different results in terms of EEG as compared to cases when you have unfamiliar smells. Well, the goal is, of course, to make a, because if I think, if you what I understand correctly, like the goal is actually, when we discussed with Mikhail, the goal is when you make a BCI, the same as you're imagining a movement like BCI, not just connect to your brain and measure the response, right? But BCI meaning that something that you can control with your thoughts, right? That, you know, you can use to control the external devices with your thoughts. Then you can have like smell imagination experience, right? And this is, of course, you will have, it will be better to do it with some familiar smells, right? Like, because you just think about how lemon smells and see if you can recognize it. That, and you can teach person to
Sorry,
properly think. Yeah, go ahead. Sorry.
but I mean, it actually never happens like that in the brain. You know, like you don't have this sort of compartmentalization where you can actually just imagine the smell of something without simultaneously imagining the image of it, the texture, and everything else. So
That's
you
true.
have,
Yeah.
you know, like basically, you know, like so it's, you know, this differentiation is kind of like a very tricky thing to do, you know.
Well, maybe, Vladimir, maybe this differentiation is not actually needed if our goal is BCI, right? Because when we think about motor imagery, right? But first of all, different people imagine movements differently, right? For sure.
Okay.
Then some, and there is even two types of imagination. You can have a kinesthetic imagination, or you have visual imagination, right? Or you can have both, like combined, right? So when you think about moving your wrist, for instance, rotating your wrist like this, right? You may think, like, you may try to reproduce some proprioceptive feeling that you get when you're moving your wrist, or you may just reproduce the image of it moving, right? So, and you can actually close the loop. And the same you can do with olfactory stuff. You can close the loop and teach the person to imagine properly, okay? So that you first learn what changes happen in the brain when the person is listening to this particular smell, right? And then you're applying, well, this is an old idea, but I'm just reiterating it here. So then you're applying this very classifier to classify his imagination and trying to teach him so that the classifier decodes his imagination properly, you know. And then this is the process of teaching to use the BCI, of teaching to imagine properly. And then you may even consider some adaptation on both sides. You know, the classifier may adapt given that the distance between different stimuli is preserved, like in the classifier space, right? And the human will learn to adapt, to imagine properly. Yeah. So something like this. But yeah, it doesn't have to be just the smell. Of course, you imagine all association. Like you think about lemon, you imagine the lemon itself. Like I tried now to think about lemon, how it smells, and I couldn't do it without imagining the lemon, you know, without like visually imagining the lemon. Yeah.
Yeah, I think especially because like we repeated this several times. How emotionally charged these other stimulus
That's
are,
true as
and
well. Yeah.
like this will affect it even more. Like you
Yes. Yes.
will. It. I mean, like the EEG will just look like like lightning in Las Vegas. Like if it's a like an especially salient smell, you will have a brainstorm. Like you will remember your first childhood
Yeah, that's
experience,
true.
and
Yes. Yeah.
so
Yeah.
it's very, I don't know. This is why I think like this choice of smell is particularly important. It should be something as neutral as possible. Like and this is maybe even try with some artificial smells or something like that. Like I would go much more with the artificial smells than the natural one, because we all have experiences with natural smells. We all have like some sort of emotional association with them. So if you try to find something that probably more or less nobody ever smelled,
Uh,
that would be a really good thing.
on the one hand, you're right, but then I think that right or wrong depends on the question. Again, if you want to
Yeah.
develop a BCI, then theoretically you want to choose smells that cause very different reaction, right? Like you want to have like 3 or 4 smells that cause very different associations, right? And alter your activity, your brain activity in the
Right.
4 most different ways, right? So you can easily detect these changes, right? On the other hand, if you want to study, if you want to do scientific study, I mean, trying to disentangle the olfactory perception, these kind of things,
Yeah.
right? And how it's represented in the head, and how you have this subsequent association with your objects or movements and stuff, integration. Then but you're right, you have to select as unfamiliar, as neutral smells as possible. Yeah. So Ivan, this is another thing you need to think about. You need to clearly disentangle these questions in your study, right? Are you moving towards the BCI, or you're moving towards scientific insights into how,
Neurophysiology.
yeah, neurophysiology, exactly. Yeah, that's the word.
Yeah.
Yes.
Well, for me, BCI is more interesting field.
Well,
And
then, yeah, then you
there
have,
I agree with you. So it will be something which person, I mean, for this case, it's more necessary that the person can recognize it and can think about it, even though it will be not. And I found it particularly interesting that it's not like thinking about smell of the lemon is not something like really simple. But if we'll be able to train BCI for those things, it's kind of, well,
yeah, I know. Here it is. I know where you sell it. That's it. That's it. That's it. So, okay, because olfactory perception is a very low level thing, right? It's like very like evolutionary, very very low, right?
Mm.
You can group people, let's say males and females, based on what changes in the brain when they perceive different smells. And then you can have couple matching, right? And you can sell it to the marriage agencies or whatever. That will be a fantastic test.
Yeah, but
Be-
this is yeah, this it would be great. Like because like I'm a molecular biologist in the like main background, and then I switched to cognitive neuroscience, and every time I think about this, I think about society today and what we are like generally biologically meant to do. Like in these kinds of thing will work for a short term relationships, like because
well,
you
I
are
don't know.
No, really, because
I
to
don't
start
know.
a married couple and see if we can see that
no,
they
the point is that you are calibrated to, like from smells and other different kind of inputs. You should, recognize the immunological compatibility and all this kind of stuff. But this is, like it's just in general in animals is just to produce an offspring. Other than that, it's not made for anything.
I don't.
So
Vladimir,
and
I think you are mixing two things. Sorry, I interrupt. I think you are mixing two things.
okay,
I'm not saying that you choose smells like a woman smell, right? No, no, no.
okay,
You choose different smells like from nature or from food,
okay,
and your brain activity. Well, if I may say so, it way it will. I mean, you will have different associations. Okay, and if
okay,
the and so it's not because like it's on a level of looking for a partner. No, you will
okay.
have associations which are different. Like for instance, if I smell lemon, I imagine something
Okay,
that's
so
pleasant
you're
to me.
looking for
And
character matching based
right,
smell.
exactly.
Yeah, yeah, okay, okay, okay.
But based on the very low level associative clues,
Right,
right?
right,
and,
right.
and that may be
Okay.
actually those bonds that will keep the couple through the hurdles of life, those common
Well,
associations.
I don't. Yeah, this actually might be. I mean, just as an experiment for me, it would be fascinating to see because when you go to this type of low level things, then you kind of circumvent all the build-ups that will later have the education, the cultural impacts, and everything else, and it would be like really interesting to see what's going on.
Yes, because what we are actually, I see a lot in my friends or whatever that we are a lot of from the childhood. Okay, so
Yeah.
we are really from the childhood. We have lots of experience, we have a lot of associations, we have a lot of judgments that we've learned during the childhood, not even already in school. Well, no, in the high school, I mean, in the university, in the high educational place. But during the first, let's say, like 10 years of more or less conscious existence, right? So yeah, well, you never know. But
Yeah, but
that's
that's the point because like the development of the brain is not equal in all parts throughout life, and like the parts that will continue to grow the longest and to develop the most is like neocortex, but all these other older structures are something that will be formed very early, and like we know now that, for example, the memories that are stored in amygdala or something like that are not even touched by Alzheimer's. So, like
Mhm.
these are, kind of very different things.
Yeah, yeah. Okay. Yeah, there is
So,
actually a
so I
message
have
from.
a more materialistic question. So, if you think that olfactory cortex will be active, right? Can you identify it from EEG somehow?
Is it deep? Where is it located? Can you show
Yeah,
the brain?
Ivan, where
One.
is it?
Oh, I know what
and
you. Show me. Show me. Yes. I have an answer. Yes, I have the answer. Hold on. Just show me. I think I have the answer. So where is it? So just point.
So it is basically in the
There it is.
insular cortex,
Here. All right, guys. They want this
or
study.
close. Yeah.
Yeah. They want this study from EEG. It will be difficult, but if you use optically pumped magnetometers, sorry, I'm saying about my stuff, but if you use them and stick them in your mouth, I guess,
Okay.
then
Good.
you will definitely be able,
Good.
because there was this recent study by Tim Turney and the UCL team, how
Mhm.
they measured the hippocampal activity very nicely with OPMs. Okay, so the same thing here. You just stick it into the mouth, and you will be able to listen to the olfactory cortex. Yeah. Well, I mean, it of course
But
depends on how the neurons are organized there. I mean, do they make
Mhm.
like do they have like long dendrites, for instance, so that they can bundle together and represent sort of a dipole, right? The big one. So that's an open question. But to be close to it, yes, OPMs.
Mhm.
Yeah.
Let's put this on the list.
Yes.
Mhm.
okay, I need to learn more about it. Right now, it sounds like Okay. Just something in mind.
OPM sensors. Take a look at optically
Okay.
potentiometer sensors. Take a look. Just type in Google OPM hippocampus and Tim Terney, Terney. You will get it. Just right, just like that. Yeah.
Okay. Well, it also will not be probably part of my first experiment, but.
No, of course. Yeah.
I also want to say that Nikita Bukreev from the Sensory Lab have finally joined the Zoom. So if you have any questions about first of all, I want to thank him for allowing me to use Sensory Lab equipment. And then if you have any further questions about the equipment, which I did not answer in my presentation, we can get back and to ask Nikita.
No, I think for me it's more or less clear, but yeah. But
Look, Alex.
if you have a comment.
My English not very well, but I'm trying to speak. If you have a question, I can just trying to say about that laboratory complex.
The question is, Nikita, let's say, what is the time between the moment when you turn on the smell onset, okay, and the time when the person is able to perceive it?
The first factor is breathe.
Right.
When the human breathe into the body,
yes,
it's the first factor. The twice it's a distance of when the smell traveling to human. It's about half of second.
Okay, half a second, you mean, right? Something like that. Yeah. Okay, that was my question, actually, Ivan. This is something you need to take into account. Yeah, that's an important. And then when you switch from one smell to another, this transitory period, how long does it last? I mean, in terms of like, how did you measure with some objective device the concentration of molecules around the nose? What is the ranging? What is the ranging curve?
We work in that point, but right now we don't measure that. But it's very good.
But you can measure it, right? Because you can.
We don't have electron nose. We don't have equipment for that because it's very
right. But you can choose some specific molecule. Well, of course, it depends as well on the size of the molecule, right?
Yes, it's a very good question. I understand.
But then this will give you some objective measurement of the performance, and maybe you can optimize the location of your how you call it, guns, right? Air guns or whatever it is. You can optimize all angles and things like that. So yeah.
Yeah. Okay. About 5 years ago, I start to make that laboratory, and my first of all interest in that laboratory, it's a research of olfactory, because all of methods which we try to apply to research don't work because we have a more complex. When you say it's more alarming, yeah, I'm sorry.
No, it's okay. You're making yourself clear. That's no problem.
Okay, and that study of laboratory позволяет. Allows to make that experiment. Yeah.
I see. Okay. No, cool. I think this is a very interesting development in our center, thanks to you.
So my question is about adaptation to smell, because olfactory system is very well known for adaptation. Like you smell first time, you smell the second time, fourth time you didn't smell at all. So what is your experience with this room? Like, is adaptation a serious factor? Like, how long should you wait to wash it out? This kind of stuff.
Wash it, what do you mean?
Yeah, like remove the adaptation effect. Make the smell fresh, new.
No, the camera have input and output.
Yeah, this is not so much a technical question, but mostly like from your experience, because you put your subjects in the camera. So like I guess when I smell it for the first time, it will be surprising and new. Next time, not so much, and then I may not smell it at all. So this, have you worked through this? Yeah.
When we use olfactory display, we start
Uh-huh.
to распылить, как
Disperse.
Disperse, yes.
yeah, disperse perfume or another water very short period. It's maybe half of second, and half of second we are waiting when the aroma goes to nose for human, and if we try to disperse it longer, we have what you mean.
It's not disperse, it's spray or something. Yeah.
We get what you mean, but if that will be short, it's okay.
I see. And also, Ivan, that's something which came to mind after Misha's question is that different people are they differ a lot in the extent to which they pay attention to the smell. Like, for instance, I have lost my first job, actually, and I should have become a nuhach. I don't know how we call it in English. I feel like very, very detailed smells, very detailed. My wife, on the contrary, she's like much more tolerant to smells, and she simply doesn't feel some of them. Okay, so you have to somehow maybe make a test for the subjects and group them, like stratify them into the different categories based on how they perceive the smells, because they're really very different in this aspect.
Yeah, I have an idea. Thanks for this point. Maybe we can just for the first pre-experiment put a different concentration in different capsules, Nikit.
Maybe,
and,
yes.
and then like turn them on and ask a person to report when they.
Yeah, the threshold. Yes, you can decide.
So
That's actually by itself. Yeah, that's by itself a very important thing. Maybe you can have. Maybe you don't need the certification, but for each person you will choose the threshold. Like, you know, when they do the subliminal stimuli, when they study the subliminal perception, right? Or for instance, you know, they adjust the threshold so that 0.5% of the stimuli are perceived, and the other half is not. You know, the half of the experience, and the other half is not. For instance. So maybe based on this curve, you can then adjust to each particular person. But you know, something like this. But it definitely has to be taken into account because if you remember my earlier comment, if the person has difficulty in perceiving smells, he or she will be breathing much more intensely, like Nikita said, right? So and that may be a big confound, and you want to avoid it. So you want to, by adjusting the concentration, you will indirectly affect the extent to which people are, you know, striving to perceive the smell.
For this, I would instruct them not to do like funny things like sniff very rapidly. Just breathe as you breathe. So
normally, yes, breathe normally. Yes.
Yeah.
Yes.
About 75% of people have anosmia. It's not full anosmia, it's parts anosmia, like that. And we can use smell identification test.
Okay.
I write in a chat.
Okay,
I'll check it out.
Yeah, that's very important. Yes. Great. Okay.
So probably we can
that was a
finish here.
Very productive discussion, I believe. Yes, go ahead and finish. Are you done with your slide or not yet?
With my slides, yes, I've been done with here. That was the last one.
Okay, that was the last one. I see. Okay, so yeah. Anybody else wants to say something?
Oh.
So my question is, like, can you fantasize about the brain activity you will see? I would guess that you will see this desynchronization somewhere, and then it will travel somewhere else. So could you maybe describe this sequence of events? Like you present the smell, what will happen to the brain? The person starts to think about this, what will happen, then he wants to generate a motor response, what will happen, etc. In terms of rhythms from, I don't know, very slow to better.
Whoa, I would not be able to right now answer the question. I will have to prepare for it. But thanks for pointing my attention to it.
Yeah. Okay, so guys, do we think that we are done?
Pretty much, yeah.
Yeah. So
maybe more questions.
Yeah.
How many people do we have?
12. So
okay,
what? So okay, 20% of questions they should be right. So 12. So one. Yeah, like 2 more questions, for instance, from the audience, from the students. Hi, come on, guys. Nobody wants to ask questions.
Okay,
Students have a very good sense of smell.
Yeah, Angelina, go ahead.
I know that there is an approach when you can simulate electrically your sensors in your nose and simulate some smell sensing, and maybe I also going to do something like this maybe in the future.
Ivan, can you answer?
Thanks for, have not considered it, but I will explore this possibility as well. Yeah.
Yeah. Okay.
But I wonder, like, for this kind of things, you can never be, I mean, not even closely precise as you want to be, because, you know, like, these receptors are very tightly packed, and you can never, you know, stimulate an area that's so small, you know, to precisely target this.
Yeah, otherwise it would be bidirectional, right, Misha? It will be bidirectional neural interface.
Like in the brain, everything is bidirectional.
No, I mean, no, I mean.
So it should be bidirectional in interfaces as well, yeah.
Exactly, yeah. Yeah, okay.
So is it not really possible to simulate sensors electrically? Receptors in the nose?
No, it's just, you know, like the, first of all, like if I'm not really sure how that would work, because like the receptor is basically an activator. It is something that tells the neuron to switch on, you know, and here by electrical stimulation, you're switching, you're, you know, like going up after the receptor and you're going directly to the neuron. So, and then the neuron fires to the brain. But the point is, you know, like you don't have anything remotely small to the size of the neuron, so you know where precisely are you targeting, you know, like, so you would be targeting thousands, if not millions of neurons at the same time. And, you know, it would be very complex to say, you know, I specifically, you know, like stimulated this or that or whatever.
So basically, it is quite possible. I mean, like there are experiments, as far as I know, that stimulate this area in terms of like generating some smell effects. But what I think it's impossible to stimulate lemon, let's say. It's just, I mean, it's just.
Yes, the same as it's impossible to stimulate a I don't know, a silk and a tactile perception. It's nearly impossible.
Yeah, exactly.
It's very difficult.
That's a separate big story about how smells are encoded, because you can recognize like 1 million of smells, and there are some smell receptors. So it is all encoded in some sort of oscillations. So this is very interesting. And I know very little about this. So that's Ivan's job to study the system.
Yeah.
So yeah, but it is very oscillatory. Like if you want to stimulate these receptors, just use some kind of oscillatory stimulation of different frequencies, and then you have a chance to affect different dimensions of smell.
Well, ideally, right? But if
And
Yeah.
what kind of smell you can perceive with electrical stimulation? Not a lemon smell, but what kind of smell?
Horrible.
Something strange?
I want to answer, but I don't can because my English is not well.
You can answer in Russian, we can translate.
Yeah.
I know a research study about that problem. It's we have that study, but I can
Speak in Russian, somebody will translate.
можно?
Да, конечно, давайте.
Там у нас около 370 генов, которые кодируют белковые рецепторы. И они распространены в обонятельном эпителии по-разному. То есть у каждого человека, во-первых, экспрессируется разное количество генов, это тоже важно. И, во-вторых, они имеют определенную структуру экспрессии, то есть у них есть определенная структура. То есть мы там ближе, там, в разные регионы, если обонятельное эпителие будем электричеством стимулировать, мы получим разные ощущения. Но большой точности не достигнем, потому что они пересекаются друг с другом, эти области экспрессии.
Okay, so brief translation is that we have 370 genes that are guiding our sensory system when it's evolved. So then there is a huge number of different receptors based on those genes, and it's different for every human, its expression. And also, but the biggest problem is that they overlap in our how you call it, olfactory bulbs. They overlap, so basically it's impossible to achieve this kind of precise smell with electrical stimulation, because they react to different белки.
No, proteins.
Proteins. Thanks, so they react to different proteins, but since they are overlapping, like those reacting to one protein and this one reacting to this one, then as far as I understood Nikita, when we're stimulating them electrically, we just cannot achieve precision.
Yeah, you're gonna achieve just a cross stimulation across all these receptors, and that's the whole point. And also the, you know, like the size of the molecules of the smell molecules is something on a, you know, like a nanometer scale or something like that. So, you know, it's a completely different thing. We don't like even what we are printing now on the circuit boards is not that small, you know, like the electrodes that we use are just,
yeah. But you know, it's actually this is a very similar problem to when the problem is, you know, to call about the artificial sensation, right? Not sensation, artificial tactile sensation, and it's also not very easy to do that. Also with visual stimulation as well, you know, visual prosthetics is if you go directly to
the resolution is terrible.
So it's just in the visual system they have a very significant progress, as they have a deep learning based model of the several first layers of the visual system, and then they were able to reverse engineer it and basically find the stimuli, like, which is completely unnaturally looking, something that would present to a monkey, and in order to, let's say, have two specific neurons fire like beyond the regular scale, for instance, okay, or they want to create certain spatial pattern, and they managed to do even that. So maybe something like this would be similar if we could measure or have a better model of the olfactory system. Then maybe we can have some.
Yeah, but the visual system is very specific and
of
very
course,
hierarchical,
yes,
you know,
yes,
like,
yes,
so
yes,
it's a
yes. And because of the evolutionary reasons, right? The olfactory system is way.
Yeah, sure. We are visual beings first, and then
Yeah.
everything else. Like, so,
Yeah.
you know, like it's always funny to me to for example, like compare a dog smell to human smell. I mean, compared to them, we're basically senseless. You know, we don't even feel smell at all. You know, like so. And then, you know, like that funny thing, why dogs always sniff their butts when they're meet each other. I mean, that's basically, you know, like it's like handling your own business card, you know,
They
like
look at the,
get
they look. This is the
all the
passport. Come on.
informations, you know.
Yes. Yeah,
Yeah,
passport.
exactly. It's like every information they need, it's right there. And you know, like they can judge their health, their, you know, like their diets, everything they need to know. It's just amazing.
Yeah.
So,
Yeah.
What is also fascinating about smells for me is that it has a different temporal dimension. What I mean is that when we look at something, it's right now, and the smell, it has this overlapping layers for those creatures that can hear it. But like dog can say, okay, here, like half an hour ago, that dog have been here, and it is like all overlapping temporally over each other.
yes, exactly. But that's just, you know, like the matter of concentration, you know, like and how fast something evaporates from a surface. So, you know, like if one molecule is enough, then, you know, if that molecule can stay there for 2 days, you know, this guy's just going to pass there and sense it, and that's just that. So,
Yeah. Okay, guys.
but
Sorry,
I think
Yeah, go ahead.
right.
Go
So
ahead.
it's just the you know, like the point is, you know, like that I always saw, you know, like both the auditory and the visual system as somehow digital, and the taste and the smell as analog system, you know, and this is why it's so really hard to translate them to digital environments. So, you know, and it's also, you know, like when we're speaking about like the encoding is the whole thing, because, you know, like this is why you have such effective hearing devices, because you know the way that the encoding is going. You know, once you crack the encoding, you cracked everything. But, you know, to get to that, it's a really big problem. So
Yeah. Okay, guys. So I think because I had to switch to other things. So I'm sorry. So I think this was very, very successful, and I think I personally learned a lot, and I think Ivan has collected some concerns of ours and will improve his design, and we will discuss it maybe in one more time, maybe in the same setting of the seminar. Yeah. So thanks everybody.